Hi guys. So I think part of this topic we're going to be talking about stem and leaf plots, and a lot of people don't know how to read them, but they're really, really easy to read. Uh, so we've previously talked about frequency tables. So frequency tables are really, really good at telling us how data is distributed, but we can't use any information on a frequency table to tell us the minimum, maximum, mean, median, or mode. So what a stem and leaf plot does, it sort of combines a frequency table with just the raw data written as a list, like what I was doing at the top, like 0, 1, 2, etc. And puts it in a table that also shows the distribution, which makes it really, really useful. The problem with the stem and leaf plot, though, is that it becomes a little bit difficult to use when you get really, really large amounts of data. It becomes a little bit more difficult to represent because you end up getting numbers, going off the side of the page, that sort of thing. So, yeah, we're generally going to be working with quite small stem and leaf plots, just to keep things nice and simple. So to read a stem and leaf plot, the stem generally will represent the tens column, and the leaf will represent the ones column, unless specifically noted otherwise. But for now, we're just going to be sticking with tens and ones. So what we've got here, we've actually got zeros, tens, 20s, and 30s. So 0, 1, 0, 3, 0, 9. This one is 15, 21, 21, 24, 32, 37, 38. So if we were actually to write out our data points, it would look a little bit like this. 1, 3, 9, 5, not 5, 15, because we're in the tens column. Now we're in the 20s column, so we go to 21, 21, 24, 32, 37, 38. Okay? So, yeah, the stem and leaf plot just shows us the distribution, shows us quite nicely with the graphic how the numbers are distributed. So just looking at the line here, it's really tricky to figure out, I guess, where the numbers are most or least distributed around the tens column. But using the stem and leaf plot, we can see very clearly that it's all pretty much even except in the tens column where we've only got one tens value, which is 15. So now to actually use the frequency table, we can use it to find a variety of different information about the data. So for example, the minimum is 1, which we can see right here. The maximum is 38. The mean. So for the mean, we need to add all the data points up. So it's going to be 1 plus 3 plus 9 plus 15 plus 21 plus 21 plus 24 plus 32 plus 37 plus 38. I'll use that with my handy dandy calculator. Let's see, 1 plus 3 plus 9 plus... Feel free to skip this part of the video if you find it boring. 24 plus... Whoops, that shouldn't be 24 there. That should be a 21 plus 21 plus 24 plus 32 plus 37 plus 38 equals 201. Let's write that up there. Divided by the total number of data points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, equals 20.1. Okay, so our mean is 20.1. I'll just get rid of that. We don't really need it right now. So the median is the middle number. Well, we know we've got 10 data points, so 10 divided by 2 equals 5. 1, 2, 3, 4, 5. There's 1. 1, 2, 3, 4, 5. There's the other one. So we've got 21 and 21 is the median. So we need to find the average between 21 and 21. So 21 plus 21 divided by 2 equals 21. Easy peasy. So again, with the median, we need to find the middlemost number. All I've done is divide the total number of data points, 10, by 2, and gone 10 divided by 2 is 5, and I've gone 5 from each end. So 1, 2, 3, 4, 5 here, and 1, 2, 3, 4, 5 here. So because we've got two numbers for the median, we need to add those two numbers together and divide it by 2. So 21 plus 21 equals 42, divided by 2 is 21, so our median, 21. The mode, is there a number that appears most frequently? Well, yeah, 21. Easy. So, here's another one. Again, we can find the min, max, range, mean, median, and mode. Range is one that I'm just mentioning because I've heard a couple of people mention it so far. All the ranges, it's the difference between the minimum and the maximum. Okay? So, in this case, our stem, as always, is the tens column, and our leaf is the ones column. But we've got 9, 10, 11, 12. Well, that means that these guys are 90, 90, 90, 100, 101, 102, 113, 15, 17, 120. So our minimum is 90. Our maximum is 120. So to find the range, we just go 120 minus... Oh. Yeah, hold on. I think I've done that wrong. No. Sorry. As I said, it's late at night. I'm only half thinking at the moment. Equals 30. So the range is 30. And all the range represents is the difference between 120 and 90. So it's, I guess, the amount that is between the smallest and largest value, which is the range. Okay? The mean, again, we're going to add them all up. I'm not going to write them down. I think you guys understand the mean pretty well. 90 plus 90 plus 90 plus 100 plus 101 plus 102 plus 113 plus 115 plus 117 plus 120 equals 1038 divided by 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's nice and easy. Divided by 10 equals 103.8. So our mean is 103.8. The median, well, we've got 10 data points, we just figured that out. So we go 1, 2, 3, 4, 5, there's one. And 1, 2, 3, 4, 5, there's another one. So we've got 101 and 102 divided by 2 equals 101.5. Oops, 1.5. So median 101.5. And the mode looks like it's 90. 90 appears 3 times. And there you go. So that is how to read and interpret a stem and leaf plot.